Section B. Explain the first come first served CPU scheduling algorithm. First come first served FCFS scheduling algorithm simply schedules the jobs according to their arrival time. The job which comes first in the ready queue will get the CPU first. The lesser the arrival time of the job, the sooner will the job get the CPU. FCFS scheduling may cause the problem to starting if the burst time of the first process is the longest among all the jobs. Advantages of the FCFS: simple, easy, first come first serve. Disadvantages of the FCFS: the scheduling and methods in non-primitive, the process will run to the competition. Due to the non-primitive nature of algorithm, the problem of starvation may occur. Although it is easy to implementation, but it is poor in performance since the average waiting time is higher as compared to other scheduling algorithms. Example: let's take an example of the FCFS scheduling algorithm. In the following schedule, there are 5 processes with process ID P0, P1, P2, P3 and P4. P0 arrives at time 0, P1 at time 1, P2 at time P2, P3 arrives at time 3 and process P4 arrives at time P4 in the ready queue. The process and require respective arrival or burst time and are given in the following table. The turnaround time and waiting the time are calculated by using the following formula: turnaround time, completion time, arrival time; waiting time, turnaround time, burst time. The average waiting time is determined by summing the respective waiting time of all process and divided of the sum by the total number of process. Write a note on semaphores. Semaphores are integer variables that are used to solve the critical section problem by using the atomic operations wait and signal that are used for process synchronizations. The definitions of wait and signal are as follows. Wait: the wait operations decrements the value of the arguments if it is positive. If s is negative or 0, then no operation is performed. Signal: the signal operation increments the value of its arguments s. Types of semaphores: there are two main types of semaphores: counting semaphores and binary semaphores. Details about these are given as follows. Counting semaphores: these are integer value semaphores and have an unrestricted value domain. These semaphores are used to coordinate the resources access where the semaphore count is the number of available resources. If the resources are added, semaphore count automatically incremented, and if the resources are removed, the count is determined. Binary semaphores: the binary semaphores are like counting semaphores, but their value is restricted to 0 and 1. The wait operation only works when the semaphore is 1 and the single operation successes. When the semaphore is 0, it is sometimes easier to implement binary semaphores that can counting semaphores. Advantages of semaphores: some of the advantages of semaphores are as follows. Semaphores allow only one process into critical section. They follow the mutual execution principle strictly and are much more efficient than some other method of synchronizations. There is no resources wastage because of busy waiting in semaphores, as process time is not wasted unnecessarily. To check if a condition is fulfilled to allow process to access the critical section, semaphores are implemented in the machine independent code of the microkernel, so they are machine independent. Disadvantages of semaphores: some of the disadvantages of semaphores are as follows. Semaphores are complicated, so the wait and signal operations must be implemented in the correct order to prevent deadlocks. Semaphores are impractical for large scale use, as their use leads to loss of modularity. This happens because the wait and signal operations prevent the creation of a structured layout for the system. semaphores may lead to a priority inversion. Their low priority process may access the critical section first and high priority process later.